Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and I am excited to be on this journey with you in this winter school, preparing for the exam by looking at your basic formula sheet for sequences and series. So in this video, we are specifically looking at sequences and series, the formulas. So on your formula sheet, you have a beautiful part of the formula sheet that is specifically for sequences and series. So what I would like you to do is mentally, as you prepare, get yourself in the mode of looking at your formula sheet and kind of, blocking out all the noise. I like to call it the fluff, the noise, the exterior stuff. That's too much. So learn to break this down for yourself. And that's what I am here for. In this first little video, in this part of it, we are going to start by looking at those two formulas. Now that is for adding ones and natural numbers. In other words, what if I add a whole bunch of ones? In other words, 1 plus 1 plus 1 plus 1 n times. Kind of a logic, hopefully, if it was sigma from I equal 1 up to 50, that would mean adding 50 ones. Hopefully you know that if I add 50 ones, the answer is 50. That's what it says there. N and N. Okay? But now, the natural numbers one is a bit more interesting. The natural numbers one is I substitute I with 1, then 2, then 3, up to n. So I'm going to have n number of natural numbers adding together. So for example, if I add the first 50 natural numbers, what the formula actually says, and now I'm using the right-hand side of the formula, n is now 50. So I can replace that, meaning the sigma from I equal 1 up to 50 of I is 1,275. Now, most of you would have never used these formulas at all, and that's fine. It's basically just a nice little shortcut if you somewhere in the test have to add 50 or 100 natural numbers together. They give you the formula. Nice. I think it's actually quite awesome of them. But let's now look at the next part of this formula sheet. The next part of the formula sheet is looking at those two formulas, specifically about arithmetic sequences or series. Okay? So when we talk about an arithmetic sequence, remember there's a definition that's not on the formula sheet. This definition says what makes an arithmetic sequence arithmetic. Well, T2 minus T1 is equal to T3 minus T2. That is the definition of an arithmetic sequence. Now, if I want to calculate the nth term or the general term, I go towards Tn, the Tn formula, where A is T1 and the difference is T2 minus T1. Or any difference between. This could be T50 minus T49. But there's a constant difference between the different terms, the follow-up terms. Then as well, you have the sum of n terms. Specifically, the first n terms, not any n terms, so that you can't use this formula to directly go and add the 30 middle terms, so T10 up to T40. Sn is T1 up to Tn added together. Be very, very careful of that. So Sn is n over 2, 2a plus n minus 1 times d. Same thing, a is term 1 and d is the T2 minus T1. But now there's a formula that's not on here. It's not one you have to know, but it is one that's very nice to know. And that is the one that says that it's n over 2a plus L. What is L? Well, that's actually just your Tn, your last term. This is a handy formula, especially when working with sigma. Let's have a look now at the next two formulas, Tn and Sn of your geometric sequences. Now, when we talk about Tn and Sn, we're going to say exactly the same, where, first of all, there's a definition. This definition already in question 1.3 we needed because they said it was a geometric sequence. Very important. When they tell you it is geometric, I love to use the definition. Next up, I'm going to then say, but what if I'm looking for the nth term or the general term? Well, A is your first term, and R is T2 over T1. Of course, there's now the sum of n terms. Again, remember that's the first n terms. But now they say a very interesting thing, where R is not equal to 1. Why do they specify R not equal to 1? Well, if I make R equal to 1, I get 0 in the denominator, which means undefined. Oh my goodness. So it's just a restriction for us mathematicians who must be very pedantic and looking for those little niggly things. So when we talk about the last formula, that one there, that is specifically for a convergent geometric series. That's very important. You can't use this formula for and all series that we add together. It must be convergent, and because of convergent, we're looking at geometric series specifically. So the definition says for us to use the formula, the sequence, the ratio of which is T2 minus T1 must lie between -1 and 1. Only when the ratio lies between -1 and 1, then we can use S infinity. Get that? It's kind of like think about driving on a bus, and you have to pick up certain passengers. If the one passenger is not there, the bus doesn't go further. So if you stop at the first intersection, R must be between -1 and 1. If you can't have that, it can't go to the next intersection. So please get that. You must first look at R between -1 and 1 before you can go to S infinity. Now, we love to ask the definition in exams, and later on we are going to look at it. So please, please, please be careful. Now, this you can always see coming like a mile away, S infinity, because the sigma is going to have an infinity sign at the top. Then I know I'm either going to look at convergent, so definition, or I'm going to look at S infinity, one of the two. So please, please, please be very careful. Now you are ready to go on to the next question. In one of the following questions, there will be a video about quadratic sequences, which is not on your formula sheet. And then, as part of that video, we will specifically look at the formulas for quadratics. So have a beautiful and awesome rest of your day. Go and tune into our next video. Keep warm, stay safe, and have a beautiful, beautiful day. This is Mr. VG signing out. Watch out for the next video where we're doing question 2 of last year's exam paper, November 2021. Keep well. Cheers.